Hi everyone. I just want to this video is like an introduction video for this WebGIS application that I developed. It's a really small application. Doesn't have too much features, but it do has a connection of the application between a geo information database and backend and front end together connections. So it's a full stack project that I developed that has application on how to do a WebGIS um, development. I hope you may find out this video useful. Um, and I'll explain how my develop process is. Before everything starts, I want to go through the brief features of this app. Currently, because I'm running this web page locally, so I'm using my local IP address, as you can see in the address bar here. For you, if you want to access this on internet, you might want to use this address here that I provided. So I've already forwarded my port publicly and connects to a DNS address, so you can access it using this address. I haven't used any back forwarding porting DNS technology like NGIS, so you still need to use port at the end of this address. All right, let's just go through the features that I have for these web applications. This web app is just trying to solve an issue that if you want to find out any locations, say in New York, that I pick, and I want to know in a certain working distance how many features that I'm looking for. Maybe restaurant, maybe grocery stores, maybe foods, um, or any job opportunities available within that working distance. Okay, so if I click a point that I want to kind of search on. For example, if this is a real estate or a land that is being purchased by clients and they don't know if there are enough POIs available around them, they can find out by just selecting them here and then drag to search a travel time, maybe 15 minutes. That would be a good starting point in New York. And he want to know whether there's enough grocery stores near that. They can just click on grocery and apply. So that would do two things. First thing is based on the network, the road network of the entire Manhattan, it will generate a isochrone, which means within this polygon, if you use this red point as a starting point, the travel time to the edge and to any points inside this polygon will be less or equals to 15 minutes. Okay, I can do this on multiple different locations. Say maybe I do this um, near the First Avenues here and apply. That will also generate a polygon like that. All right. So that's what this polygon is telling. And another thing that is telling inside it is these green dots. So each of these green dots represents a POIs. And since I'm selecting groceries, that means groceries in this case. And if I select bank, then it will be all the banks available inside here. This data is being provided by OpenStreetMap. So any features that has been recorded into OpenStreetMap, it will be showing up on here in this case. And there's a count of total number of POIs in this case on the top left. And there are 6 banks here, and which I will know in this case. You can also select multiple different POIs that will just count all of them together. And each of these green dots will still represent one of the POIs here. And one more features that this web application provided is the count of jobs. So jobs is a little bit different because jobs I use census data instead of OSM data, and what I do in jobs, if I do that, you will see that they have different sizes of circles because at each point the number of jobs that being counted during the census check is different. So the larger the circle, meaning there are more jobs on in there. For example, in this small circle here, there might be only 20 or 30 jobs available there, but for this larger one, since it's a higher building and larger office buildings, there might be hundreds or 200 jobs inside there. And the summary of all the jobs, like all the points, the job it contains together as a sum is being represented on the top left as well. So it's that simple. That's all the features that you have for this app, and you can click any points on the map and regenerate this polygon. And you will see that shape different because there might be walls, there might be networks that are not available for walking. Um, People cannot pass there, so that makes the shape more narrowed. And if you pick any major avenues in the corners, that will make the polygons more spherical, like this one. So yeah, and I will briefly explain about how this works in the back end. Okay, we have seen how it looks like in the front end. I will just briefly walk about how it looks like in the back end. So I have this WebGIS structure that the structure that I access. So in this diagram, what it shows is if you are the client who is using this web application, what you are sending to the browser, and how this browser communicate to the front end, the back end, and then to the database, and how the database resend the data back and goes to the front end to present the data. Okay, so what you did, like I showed in the beginning, is the client will select a center point. That the point, which is the red point that I just showed here, that click on the map, will be the center point of the entire isochrone. All right, and you can select either POIs or jobs in that case. That's what we're doing there. And then next is the center point's coordinates with the projection that we have calculated. In this case, I'm using Web Mercator 1984. So that will be converted into Web 84 because this to make the map looks better, I use Web Map Mercator projection on this map. But in the backend, we are using WGS 84, which is a bit different. So that will be converted in the front end, and then recalculate that point coordinates and pack it into something that we will send to the backend later. And it will also tell the backend what data is being requested, right? If I'm requesting whether POIs or jobs, so the backend need to receive the information so that the backend can request the data that is desired by the clients from the database, right? So that is being packed into a database read access request because the database itself has some permission management, and we don't want our client to have any write permission, right? I don't want the clients to kind of rewrite, and modify the backend since they are not the professionals to do that. We only want them to read it. So that control is being granted by the backend. The backend will do that. So if I opens up the source code, which we use in this case, you will see that in the backend there will be a kind of configurations to connect to the backend, and in this case, is here. So this is just a temporary password. So I just show you here, but you can see that I'm telling the backend that what kind of permission that he should use and communicate with the database, right? What kind of user should be granting access, and that kind of permission management will be handled to the backends and database. So database will not give access to anyone with this user's access, so that this user will not have write permission. They can only read the data. All right, so that's what this grant access means. And most importantly is the JSON data requesting being sent. And in this case, the backend would, based on what kind of data request is being used, they will send different SQL queries. And in this case, is here. So they will kind of send out different SQL queries to the database. In this case, it will be a string, and then that string will be converted into SQL sequence, so that the database would do the search using this different SQL queries that the backend is sent to them. And here POI type will be granted using arrow functions to the database as well. So here you see that font type, POI type is being sent to the database. That is the same as if you type from maybe NY banks, NY groceries. That's the same thing, but in in order to automate it, that I use point type here to handle it. Okay, so that part is the sending part of the backend. All right, and all of this is being sent, and then now everything will be happening inside the PostGIS database. So database will receive the database security information so that it knows who is asking for the data and give it the correct permissions. And then it will also know that which database, because inside my database there are multiple inside this large database, there are different sub-databases being stored inside it, and they need to know which database they are accessing. And in this case, it's the NYC, which you will also see in the source code here. It says database NYC. All right, and also database IP address is also accessed here. But in this case, since my database and the backend are on the same server, I just use localhost here. All right, and then the database set queries and the generate isochrone queries will be sent to the PostGIS. And I will explain in the database side what is happening inside this black box. Okay. So after this query is being sent, inside the database, I actually prepare two things. One thing is I generate a network. This is a one-time generations, so that there will be a topology being generated inside the database, so that you don't need to recalculate this thing every time. It's like you do Google Map, right? If you use Google Map, you search how do I get from downtown Manhattan to lower Manhattan, right? And it will tell you this path really quickly. It didn't calculate that, but it stores that inside a graph. And the graph tells you what is the time spent on each road. Okay, so if you have learned any pathfinding algorithm like A-stars pathfinding or Dijkstra pathfinding, similar to that. I won't explain that too much in detail because that is being included inside PostGIS functions, so you don't need to write too much about that. You can use these PGR create topology functions to actually generate that table to store the source and target. So if you go back and look into the schema here, and there's a table where it stores all of these informations, which is here. All right. So in this column, you will see there are boundaries and also the length and time cost and what is the source and what is the target. Okay. So once that is being generated later on, you don't need to redo this again. So that's like a prerequisite before you run anything inside a database that you want to do anything relates to pathfinding. And what is being sent actually by the backend to the database is this SQL queries. It's the same thing as I written in here, but I just write it in SQL query so you know what it means. What this do is it will kind of using a point that passed into the database. In this case, I use a sample here, starting in it's somewhere in the central park. And then in the backend, this thing is being generated using the coordinates produced by the front end. So if you go here, you will see long let, and this two will be the one that is being passed by the front end. Okay, and also the projections that is being used. In this case, 4326, which is the map nomenclature, so that it can reproject to the WGS 84, which should be 376 something. Okay, and that would do is we'll calculate that polygon being generated in our map. This polygon will be generated. Okay, that is what this entire SQL queries is doing, and then that geometry of the polygon of the isochrone will store into this isochrone history. Okay, and what this isochrone history means is it will have a list of different isochrone being requested. All right, so in here we have this isochrone history, and then it has different isochrone being generated. Like there's a timestamp telling you when is this isochrone being generated, etc., etc. Yes, and that's basically how it looks like. So you can see this. So what is good for this is that we keep a record of the history of searching, right? Like just now, 2 minutes ago, I generated isochrone, and then it's being stored here, and this is the geometry converted into 16 digits format. All right. And next is it will generate the POIs within it, right? Because I already store a lot of POIs inside this huge map, but I want to crop them out using this polygon. I want to only leave what is being within this polygon and not showing all the other things there, right? So what I did is I used this SQL queries, and it's really simple. It's just using the top of this data of this table, because this is the one that is being generated the latest. So we are only using this one, and then it pick up this one, and then it will crop what is within it. Okay, and so it will select what is the POI. So this is also sample again, because in here we will pass them the name of the POI, right? And here I'm using NY Bank because it's a sample, and you can replace it to anything. It can be NY Food or any other things, right? It will crop it. So here you will see these restaurants, right? If I choose bank, then it will be bank. Okay, so it will crop everything, but only leave anything that is within the isochrone. And this is also, you don't need to write it inside the database, because that will be passed through the backend. Okay, and I'm just showing this as an example to you guys. All right, and after all of these things being done, I already get the point that I need, right? This is the point that I need, and I need to pass them to the front end. So that will be the opposite side of what we are doing, which is sending this in a JSON format. So by default, the table that generated inside the database, you cannot pass it to the front end, because front end won't recognize it. You need to convert it into JSON format. And in this case, there is an internal function that you can do that, which is the foreign path here, and the POI result will be iterate through it to convert it into a more neat JSON formats. Okay, so that's what is being done here, and then that will be passed to the front end and deal with it. Okay, so this JSON format will be passing into the front end, and the front end will be kind of determining whether it is a POI JSON or the jobs JSON, because jobs JSON will contain the size of the circle, right? Which will be the column C000. I've also posted here. So there'll be two different JSON. You need to recognize which JSON it is. And if it's job JSON, then it will count the coordinates and the C000 together to display them, in the open layers. And if it's just POIs, then there's no size, right? It will just sum all the number of points on the top left. It will just be the total number of points. In this case, it was 1 point, then it's 1. Okay, great. And then this will be passed, and then points will be displayed, and then the size will also be displayed. That will be like the front end code here, which I showed. I've written in the front end, in the containers web page. In this page, you will see that I am kind of, first I need to connect to the backend, which is this IP address of the backend. If it's public access, it will be this one, but currently I'm using it locally, so it's not. It connects the backend, getting the response, and then receive that JSON to kind of convert it. And you'll see that if it's a POS that has C000, then it will use the C000 as the size of the circle. This is a function that writes below here as add point, and add point is also using get point features, which will tell you the coordinates and the color, which is here, and it will also get the radius if it's a C000 that received from jobs database. And yeah, that's pretty much everything. And I want to also just make a conclusion of all the tech features that I used. First is the backend. I'm using JavaScript because I can write backend and front end using JavaScript together, so I don't need to switch between languages. I didn't use Python. In this case for backend, and for the front end, I actually also use JavaScript, but I use a library called Vue. It's something really similar to React, but it has more mature features that you can write to connect with open layers. And OpenLayer is just another data libraries that you can use to draw maps. For example, this base map, which I obtained from OpenStreetMap, is I do it using OpenLayers, because when I zoom out, you see that you need to change the source to change. So you see as I zoom in, there's more detail being shown, but as I zoom out, there's less detail to be shown. That's called tile generation, and that feature is being provided by OpenLayers. Okay, so that is what is happening in the front end, OpenLayers and Vue. Okay, and obviously in the backend there's also database, and for database I'm using PostGIS because PostGIS has PostGIS as extension. If you go to extension here, you see there's PostGIS SQL and PostGIS. These two will help you calculate and store the geometry data and GIS data. So those are kind of necessary before you're actually using this database. And great, I think that's everything I'm covering, and hope you like this video and hope that help you understand how you can develop a full stack WebGIS application. Thank you.